Division properties of exponents. Okay, now when we have 4 to the 5th, that means 4 times 4 times 4 times 4 times 4. And when we have 4 to the 3rd, that means 4 times 4 times 4. Now, since we're dividing 4 to the 5th divided by 4 to the 3rd, this is what it would look like. 4 to the 5th over 4 to the 3rd. And one of the things we know is that the 4's can cancel out, these 4's can cancel out, and these 4's can cancel out, because 4 divided by 4 is 1 in each instance. That leaves us with 4 times 4 on the top, which would be written as 4 squared. So, the question that we have is, how do we go from this to this without doing the middle part? Well, let's look at the exponents. We've got a 5 here and a 3 here, and we end up with a 2 over here. How do you suppose we did that? What shortcut could we take? Right, we can subtract the exponents. 5 minus 3 is 2. So you wouldn't have to write this out every time you did something like x to the 100 divided by x to the 98th. You could just subtract the exponents and get x to the second. Now, it makes sense that, just like you've learned in the past, when you are multiplying powers, you add the exponents. So when you're dividing powers, you subtract the exponents. And so that's the rule that we have. To divide powers with the same base, you subtract the exponents. Alright, so we've got 2 to the 6th over 2 to the 2nd. We go 2 to the 6th minus 2. Let me write that down. It's 2 to the 6th minus 2, or just 2 to the 4th. This one will be x to the 4 minus 7, or x to the negative 3. And remember, when something's simplified, it doesn't have any negative exponents. So to simplify this, we make it 1 over x to the 3rd. Okay, we'll do one more, and then I'm going to let you do these bottom two. So we've got m to the 2nd over m. See, you treat this as two different problems. We've got m to the 2nd over m to the 5th, and n to the 4th over n to the 3rd. So we'll do m to the 2 minus 5 over and n to the 4 minus 3. So that gives us m to the negative 3, n to the 1. And when we simplify that, we get n to the 1 over m to the 3rd. Alright, do you see how we're doing that? Alright, try these bottom two. Try this one. Pause your video. Try this one, and then come back to me and we'll do the next one. Alright, we've got k to the 6 minus the exponent when there's not one there is a 1, and j to the 2 minus 5. That gives us k to the 5, j to the minus 3. And when we have a negative exponent, it tells us to move it to the other side of the divisor line. So this is telling us to move it down. So we've got k to the 5th over j to the 3rd. I hope that you got that. Now pause the video, do this one, and come back to me and we'll see how you did. Alright, so you notice right away that the x to the 4th go away because one number over itself is equal to 1. So those cancel out. We've got y to the negative 1 minus, and this is an easy place to make a mistake because people see the negative 1 and the negative 5 and they assume that negative is part of the subtraction that we're supposed to do. It's not. See, what you've got to do is go negative 1 minus, well, I didn't write that down, did I? Negative 1 minus a negative 5. And see, that changes everything because that's going to be y to the negative 1 plus, because a minus minus makes plus. And then we've got z to the 8 minus, and when there's no exponent there, there's a 1. So that gives us y to the 4th, z to the 7th. Okay. Now dividing numbers in scientific notation. Remember when we had 6 times 10 to the 12th and 2 times 10 to the 3rd? What we did is we multiplied numbers times numbers and powers times powers, and then we adapted it so that it went into scientific notation again. Okay? Well, we're going to be doing the same thing, except this time we're going to be dividing. So what do you suppose we're going to be doing? If we multiply numbers by numbers and powers by powers, this time we're going to be dividing numbers by numbers and powers by powers. So let's see this. We've got 4.2 divided by 2.1. 4.2 divided by 2.1 is 2. And 10 to the 8th divided by 10 to the 11th is 10 to the 8 minus 11, which gives us 10 to the negative 3. Alright, let's try this one. 3.1 divided by 1.24. If you put that in your calculator or if you do it longhand, you'll get 0.25 times, and this is 10 to the 4 minus 2, which gives us 10 to the 2nd. Now this is not in scientific notation because this number, the coefficient, is not between 1 and 10. So we've moved the decimal over one place to the right. We make this number a bigger number. It was 0.25 and now we've made it a bigger number, 2.5, times, since we made the coefficient bigger, we'll make this smaller by 1. Okay? Alright, pause the video, do this last one, and let's see how you do. Alright, so did you do 4.5 divided by 9, or did you make the mistake of thinking this was 2? Because a lot of people do that. They say 9 divided by 4.5, and they think that the answer is 2. But I hope that you did 4.5 divided by 9 and got 0.5 times 10. This is 3 minus 7. So 10 to the 3 minus 7. So that's 10 to the negative 4. So we make this big number bigger because it's got to be between 1 and 10. That means that we make this number 1 smaller, so it's going to be negative 5. I hope that you got that. I'm sure that you probably did. Alright, raising a quotient to a power. Remember, the quotient is the answer to a division problem. So when we look at this, we've got a over b to the n. Just like before, whenever we had a power on the outside of parentheses, you apply it to everything inside the parentheses. So the n goes with the a, and the n goes with the b. And you end up with a to the n over b to the n. Okay? So when we look at this one, the exponent 3 goes with this 3, and it goes with this 5. So that gives us 3 to the 3rd over 5 to the 3rd. And when we simplify that, we get 27 over 125. Alright, pause the video and then try this one and then come back to me, okay? Alright, so the 3 goes with the z4 and the 3 goes with the 5. So that gives us z to the 4 times 3, or 12, over 125. Alright, now, taking something that you just learned and applying it to this, you know that the negative n is going to go with the a and with the b, which means you're going to have a to the negative n over b to the negative n. Now the difference between this one and the last one is that you're dealing with a negative exponent. Remember, a negative exponent tells you to move the power from one side of the divisor line to the other side. This is the divisor line. Okay, so that means we move this one to the bottom, and we move this one to the top. So it's going to be b to the n over a to the n. Now, look what happened. We had a over b to the negative n, and we ended up flipping the a over b to b over a, and the exponent became positive. So, whenever you have a negative exponent, you flip the fraction and make the exponent positive. So let's try this one. We've got negative 3. That's going to go with each one of these. So that gives us 5 over 3. We flip the fraction and we make the exponent positive 3, which gives us 125 over 27. Alright, try this one down here. See what you get. Pause the video and come back to me. So, we flip the fraction. We make it 5 over z4. And we apply a positive 3 to it. So that means we're going to have 5 to the third over z. 3 times 4 is 12. So that gives us 125 over z12.